All right, so we're going to go ahead and dive right into consolidation. First thing we want to do is we're always doing our visual, we're always cleaning. So first thing we want to do is disconnect the hash board from the control board. We do this at the hash board side because we're going to be needing to remove these hash boards here in a second. So once you got these removed, we can go ahead and now work on the control board. And we can also take a look at the hash boards. Now, of course, make sure you're checking your warranty. We don't want to take them out if it's going to void your warranty. All right, so once you remove the fan, you can get access to remove the hash boards. So we'll go ahead and pull out all the hash boards and we'll do a visual inspection. Again, we're going to make sure that all the components on the main circuits look okay, especially like the MOS chips. Just make sure we don't see any kind of corrosion, missing parts, anything looks out of place, heat sinks are crooked, that kind of thing, because then we don't want to plug it in. If everything looks good on the hash board, we're going to go ahead and put it back in the unit. And then we're going to go ahead and work on the control board. The ones that we send out will actually update the firmware for you before we send it out to you. So that way it'll be currently up to date. And as stated, it can do a bunch of different models. So when you're using this unit, you want to make sure that you're not plugging this in directly to like your computer. You want to make sure that you're actually using a block for it. So you want to make sure that you're using at least a 2 amp regular USB block to power this unit. That way it'll be as stable as possible for the frequencies that go through the actual unit. It'll give you a more accurate diagnostic. So go ahead and plug it in. So the way this works is that you have to connect to its Wi-Fi, and then the password is going to be STASIC tester, all lowercase, no spaces. Also connect your computer to internet via Ethernet connection, because otherwise you're connecting the computer's Wi-Fi to the jig and you won't be able to access the internet. So the only way to bypass that is just make sure that you have an Ethernet connection. So now once we're connected to the actual STASIC tester, we're going to go ahead and go on to the web browser. And you want to type in 5.5.5.5 dash or slash menu. As you can see, it has all the different models here. Here's some What's Minor, InnoSilicon, even has Aladdin, InnoSilicon, Aixen, eBang. So it has a whole bunch of different kinds of models that you can work with. So you want to make sure you're using a variable power supply for this. You don't want to be using even the manufacturer's power supply unit. It needs to be an actual variable. This will help keep the signal very stable. So when we're connecting, we always put the ground first, which is right next to the I/O data port. Then the red lead second, which is positive. Then from there, we want to connect the data cable. Now it's important to note that on the STASIC, it actually has 2 different kinds of connectors for male connectors. The smaller one goes to your actual hash board, while the bigger one goes to your STASIC unit. From there, you want to connect your hash board. Then we can go ahead and click on the model. This is a S19 regular unit. And as you can see, it shows you all the different chips and where they're located on the board. So we'll go ahead and power on our variable power supply. Want to set it to between like 13, 14 volts. If in doubt, you can always go and look at your power supply and see what your output is. And then you usually want to put it on the higher end of the voltages. So as we're looking at the power supply, we want to make sure that there's no amps drawing right away, at least for this board, because we have MOS chips that are going to stop that voltage and current from flowing. So we'll actually see it showing 0 amps. So we'll go ahead and press the start test button. And we can see all these chips are good. Now it's very important that when you're using a test jig or a test fixture, that you're always calibrating your test jig to a working board. That way you can verify that yes, it will indeed work on a working board. So now when you're doing a test on a broken board, you know it's going to work proper. Now you can also, with this unit, you can read the temperature sensors. It'll show you where they're placed on the unit as well. And you can also update the EEPROM info on these boards. Now you can, while you use the start test mode, you can go ahead and test different test points. So for example, we want to set our multimeter to DC voltage. We can then go ahead and put our black lead or negative lead on ground and our positive lead on the power. Now we can see the voltage coming in. We can see the voltage coming after the MOS. We can also see the boost. So one interesting thing to point out about this tester is that it kind of sets the amps up and down on the board. So that way it's not really putting a whole bunch of current through those traces and everything. So it helps prevent the board from overheating. Sometimes we need to actually connect the test jig with some fans on it to cool it down faster. So go ahead and turn off the power. We can stop the test. Now we want to do the opposite. We take off the data cable first, then the power, and then the ground. So that shows exactly the ASIC tester does. So now we'll go ahead and try a few different other test jigs. All right, so when we're consolidating, we're basically doing troubleshooting of the miner, or the unit as a whole. So we want to go ahead and flash the control board with an SD card just to be safe, making sure that there's no viruses on there. We don't want to just hook it into our network. So once you flash it with the SD card, you can go ahead and log into it. You want to update the firmware to the current firmware, make sure it's the right model you're actually working on. You don't want to, put an S9 onto an S19, for example. Probably easier to do the 17 to 19, but making sure that the firmware is good. We also want to make sure we're setting the pool settings as well. We're doing this with the hash boards disconnected. And so once we have the whole control board set up properly, we then can reconnect the hash boards, of course, being that they pass the visual inspection. So these pass the visual inspection, we can go ahead and plug it back into the control board and power everything up. Then we want to go ahead and see in the kernel log as well as the miner status, seeing what's going on with making sure the fans are working properly, making sure that the hash boards are showing all the ASICs. Maybe it's showing some ASIC, that kind of thing, in the kernel log. We just want to make sure we're documenting all this kind of stuff. So that way, if we do need to do some hash board repair, we can go ahead and know exactly where to start. And that's kind of the basics of consolidation. We're just trying to figure out what exactly is wrong with the unit. Is it the control board? Is it the power supply? Is it the hash boards, or just one of the hash boards causing the issue? That's what we're just trying to do. We can also use our multimeter as well to test the voltage of the power supply, make sure that it's actually outputting what it's supposed to. But other than that, that's kind of the basics of consolidation and minor troubleshooting. From there, once you actually figure out what's wrong with it, that's when we move into doing chip level and board level repair.